Alright students, till now we have learned the properties of addition, subtraction and multiplication. Now let us learn the properties of division of integers. So here the properties will be slightly different. The property 1, as we have been discussing, obviously we discussed the closure property. So if I take two integers, let's say a, and if I divide by another integer, let's say b, the result may not be an integer. This is very interesting because a plus b result is always an integer, a minus b result is always an integer, a into b result is always an integer, but a divided by b is not integer, obviously always. Okay, as an example, suppose I am dividing 6 by 2. 6 by 2 is 3, so 3 is an integer. This time closure property is followed. But if I divide 7 by 2, 7 by 2 is 3.5 and this 3.5 is not an integer. That means, in short, in case of division, closure property is not always followed. Done. Now let us go to property 2. Now what property 2 says? Property 2 is related to commutative property. Right. So what we have been learning till now? A plus b is always b plus a. A plus b is always b plus a, obviously. It will be repetition. A minus b is not always b minus a. A into b is always b into a. Okay. In case of addition, subtraction and multiplication we have discussed. Now in case of division, a divided by b is of course not equal to b divided by a, because if I take a 6, let's take an example, 6 divided by 2, this is obviously 3, but 2 divided by 6 is not 3, rather it is 1 by 3. So in case of division, commutative property is not followed. Okay. Now let us go to the third property, that is the property of associativity. Now let us observe what happens here. So if I take a divided by b divided by c, is it equal to a divided by b divided by c? Of course not. You can try this with the help of taking an example. So if I take an example, 10 divided by 20 dividing, let's say, 40, of course this will not be equal to this. Okay, so you can check this one. Please calculate the left hand side and right hand side, and then you check the answer is matching or not. Obviously they will not match. So in case of division, associativity is also not followed. Now let us go to the fourth property. The fourth property is related to dividing by self. Dividing by self means if we take an integer a and divided by self means by a. নিজকে যদি নিজে divide করো a by a, this will always gives you 1. However, there is a condition here. This a cannot be 0. Why? Why this condition is necessary? Because if a is 0, I will have 0 by 0, and 0 by 0 is not always 1. Okay, this is important. A by a is equal to 0 until and unless a is not equal to 0. Okay, this is property 4. Now property 5 is dividing by 1. Dividing by 1. Now this means if I take an integer a and divide by 1, this will always give you a. So 0 also if I divide by 1, this will always give you 0, same integer. Okay, So this is property 4 and property 5. Now let us go to property 6. 6 is interesting, dividing by 0. Dividing by 0. Now this property says if I take an integer a and divide by 0, this result is not defined. We don't know the value of a by 0. Dividing a by 0 is not possible. It does not exist. Very, very important. Please try to remember this property. Now 7 is regarding dividing 0. Dividing by 0 and dividing 0. These are two different terms. Dividing 0 means if I divide an integer, if I divide 0 by any integer, this will always gives you 0. So 0 by 5 is also 0, 0 by minus 4 is also 0. Dividing 0 by anything is 0. Done. Now let us go to the last property, that is property 8. So if you have a greater than b, then if we divide a by c and b by c, this will be still true if c is positive. We have discussed this property in case of multiplication also, but a by c, b by c, the sign will change if c is negative. Right? If you recall, while we are studying multiplication, we have also discussed this property. All right. So these are all 8 properties of divisions. I have discussed all of them, taking examples in details. All right. So in the next video, we shall be discussing about powers of integers.